Good morning, everybody. My name is Matt Sump. I'm our Illinois and Iowa Mastercam account executive. And then I also have Joe Julian here, who you guys might recognize the name, has been on our tech support staff and is also now our Simco and probing sales engineer. So just to give you guys a brief overview of what probing is in Mastercam. So those of you that answered that, yes, I have probes, but they're a different brand. It's mainly for, it's Renishaw's Productivity Plus software built directly into Mastercam. You can use the probe software to update fixture offsets, tooling offsets, program and part orientation. You can report on critical dimensions and tolerances of parts, and it can also assist a lot in what we call lights out manufacturing. So say you're machining a 4-inch bore on a part. So say I have to machine a 4-inch bore on a part and it's an unattended operation. The probing software can essentially go in there, check the hole, and let's say the hole is a bit undersized because you have some tool wear. The software then can communicate that back via the probe reporting, update the tool offset on the machine, and then rerun the tool path so that you're getting to size. And then after it reruns, you can then double check it and run an inspection routine on that particular feature. So that's where we see a lot of power in this, in that you're able to essentially use the probe as a tool to improve the process without having as much human intervention. So what do you need to use it? You need at least a Mastercam base mill or higher license. So mill 3D. If you have a multi-axis license, they'll all work under there. And then I have a PDF here, but I realize it's a little confusing to show on the webinar, so we're going to skip across it, but we can certainly send that to you. But essentially, if you have a Renishaw probe on your machine, you have the mill software, and then you add this package to there, and then there's a couple other variables that we found that's best to just talk with a customer directly on if you're a good candidate for the package or not. But you need to have open variables on the machine. The Inspection Plus software needs to be added to the machine tool, as well as a couple other small details. So a question I get a lot, we get a lot of people that call us in about the probing software, and as a sales guy, I always almost like to disqualify someone first, because I don't want to sell you something that you're not going to see the value in or see a return on investment. So, if you're just picking up simple work offsets with your probe, and that's basically it, that's typically easier handled with the macros that are built into the specific machine tool. And a lot of the machine tools have really quick and easy ways to pick up work offsets with the probe. Now, that's not to say that we don't have customers that use this for that function and almost solely, because getting back to that lights out example, the less operator or programmer intervention that you want in the part, it can certainly be viable and worth the investment depending on how much of that you're doing, or maybe you need to pick up a bunch of work offsets on a horizontal machine tool. So like I was talking a bit before when I was first describing what this is, some good examples. Updating the tool offsets is very popular, and also doing tool offset checks for either, just wear in general, or maybe after a certain amount of distance the tool path is ran, or you can do it time-based. Say you're running a big production job and you want to update those tooling offsets every hour of runtime. You can set it up that way, because basically the whole thought process behind this is that it's using if and then logic with the probe. So if X happens, then update Y. So any of the examples you'll see Joe go through, you'll see some of how that works. Another popular that I mentioned briefly, but is coordinate rotation. So, if you're doing multifaceted sides of a part, or a part orientation. So say you're working with a casting, and we all know that castings aren't exactly the same every time, and maybe you have a really nice soft jaw sort of fixture set up to accept that casting, but no matter how many times you clamp it down, it's not going to be 100% exact, depending on your tolerances of where that's going to be. So we can run a routine, double check the location of the part, and then adjust the coordinates based off of that. Machines are supported. This list has grown quite a bit in the past couple versions of Mastercam. The big limitation right now is that it's not supported on turning centers. But as far as mills go, Haas, Doosan, Mori, most Fanuc-based, Heidenhain-based, and Siemens-based machines are supported. Herco's supported. But really the best way to find there if your specific machine is supported is to reach out to us, and we can start discussing the fit of the software for you and what it would take to get your specific machine tools supported, because there's the software side of the actual Productivity Plus add-on in Mastercam, and then there's implementation on the post as well as on-site to get everything working flawlessly for you. So what are some of the benefits? And I've touched on this already a bit, but wanting to use the probe for more than just work offsets, or maybe the routines to do in-process inspection on the machine might be a little cumbersome, or you just want to make sure that all the probe routines are set up before that program hits the shop floor, so you're not reliant on someone else to make sure a certain probing routine happens throughout the process. So that goes into this process control point, in that all the probing routines are self-contained in the NC file. So when you see a posted program from a Productivity Plus added program in Mastercam, you're going to see all that if and then logic within the NC code. So it's self-contained and travels along from job to job. And that also gets into predictive process and the smart machining, I think, tie into each other in that you're getting an in-process state of the machine components throughout the job. So you're essentially adding intelligence to the program to get the most out of it, and cut down on cycle times and all the benefits that go along with that. And the reliability point too just ties into kind of bringing all of those points together, in that you're, as I've already mentioned, reducing the amount of human involvement and potential issues in communication throughout the shop floor. And then another benefit is the efficiency aspect of this that I've touched on here, which, if your work offsets and, tooling offsets and everything is all dialed in, you're going to maybe cut down on the amount of air cutting you're doing, especially if you're working with a casting or a forging. If you have that coordinate specifically dialed in for that specific casting, those first couple passes, even if it's, a big part, that can be a lot of time if it's just wasting time cutting air because your height offset isn't exactly correct. What are some of the challenges to the Productivity Plus software? Let's say you don't have a run-a-shop probe, like a couple people answered. There are other options for you to do, and we've done a lot with customizing post processors for specific customers. There's also other workflows that you can do to still add some of this probe technology into the part, even if you don't have the Productivity Plus. But as you guys will see in a minute here, when Joe goes through it, you'll see some of the power that the actual software has. And then the other challenge, I did these in reverse order, but just getting everything set up, depending on the specific machine tool and what version of the Renishaw software you have, there's a lot of variables to dial in and make sure that everything functions flawlessly for you. So that's why when we quote this out for a specific customer, you'll typically see 3 line items on the quote. One's going to be the actual software add-on to your current Mastercam package. 2 is going to be the post-processor modifications. There's a handful of different files that need to get set up so that it talks with the Renishaw software that's on the controller. And then the third part is a training implementation portion of it. So we always come on site and it's essentially a requirement of getting this package because we're making sure that post modifications that we've made interface with the controller properly, that the open variables for the probe routines are set up correctly, and then lastly, just training on how to actually use the interface. Because the interface is essentially a direct plugin of the Renishaw software just right within inside of Mastercam. So the actual dialog boxes that you guys are going to see aren't going to look, you know, like a Mastercam mill toolpath that you've been doing for years. So, you know, like anything we sell here at ShopWare, we want to make sure you're effective with the tools that we're providing. So with that being said, we're going to take a second here to pass it over to Joe.
I was wanting to bring up a couple updates to Mastercam 2020 and Productivity Plus. So with 2020 being released here, an update to Productivity Plus in here now is that we can actually post out probing cycles with our default MP fan post. So this should be kind of used with caution, obviously for any toolpath that you might be running, generally here. It might not run on your machine per se, but it is good to kind of see the code output, in the meantime before ShopWare can get out there and prove out your machine. So that's what we're going to be using today for quite a few of our examples. And another update that we have here for 2020 as well is that probing used to require wireframe, but now we can, in 2020, it now supports probing off of solid edges and other model features there. So those are kind of the two main ones here. Another thing I wanted to mention as well is that as we're going through the examples here, I just wanted to point out some of the help menu that's in the bottom of the toolpath manager here for each of the probing toolpaths. It's extremely helpful and it's very informative for everything that some of the dialog boxes might display. So it's very good for practicing and familiarizing yourself with some of the jargon and language inside of those paths here. I'm going to start kind of with the basics with building a probe directly from Mastercam here. Then I'll get into calibrating your probe, updating work offsets like Matt said, setting tools, generic probing routines in Productivity Plus. Then I'll get into a little bit of 3+2 or rotational update programming in Productivity Plus, and then we'll get into the if-then logic with adding that smart machining into your process. All right. So without further ado, I'll get started here. So whenever we pull up a probing path in Mastercam here, it's going to ask us to define a probe. So under our utilities subsection in our toolpaths tab up here in Mastercam, once we hit our probe here, it's going to display our prompt. And we can choose to edit the sample probe that comes with Productivity Plus, or we can go ahead and completely create a new one. If we have a specific probe database as well that we want to update into our new software, if you're a new user, comparing from another user that might have a little bit more experience, we can import that as well here. So I'm going to go ahead and just kind of demonstrate creating a brand new sample probe here. So if we go into here, we get this edit probe dialog. We can go ahead and give our probe a name. So we can say, probe plus example. Now, depending on how your machine runs the offsets, we're just going to give our tool the tool change ID. And depending on what your machine takes, we'll either match that or give it a different offset here. In our probe module, we have a drop-down list with a few of the Renishaw supported probes inside of Productivity Plus here. So as we select one of these here, we can see that the window to the left changed with our selection here. So I'm going to go ahead and select an OMP40. And then for our stylus, we can select that as well here. I'll go ahead and choose a 75 millimeter. And then we should be good to go. So the way this works is that, the way that this works is that anytime we update or create a new tool, it writes that data to a library, kind of like a tool database library inside of Mastercam. But obviously it's going to fall in a different spot in Mastercam here in the general directory. So if we say OK to that, we can see our Productivity Plus probe installed into our list here. We can go ahead and say OK. So it'll say the database has been modified, and then we can, yes, save the changes. So after we select our probe and we define it and everything like that here, we're going to get our dialog here. So just going through some of these options here, these are going to be your kind of generic probing routines here. So we've got point, measure a line, measure circle, measure a plane, a 2D corner, a 3D corner, and web pocket here. So as we go along through the examples here, we're going to be, obviously displaying the functionality of some of these here as well. And these over in this area here are going to be what you do with the cycles and the data that we get from our generic probing routines here. So we can almost construct a point from two separate lines, or maybe a midpoint of a line. Between two, maybe something like two circles, we can construct a line and then measure that and report that data back, and construct a circle as well here. I believe this is going to be our constructed plane. So in terms of these are very powerful in terms of, we can store these these data points here. We can store all that in our machine directly, and then be able to call those variables back up as we post out our code. Okay. I just saw. Oh, sorry about that, guys. I saw the a couple of the questions inside of our window here. Okay, very good. So in terms of the other kind of icons inside of Productivity Plus here, we have inspection cycles, machine updates, where we can update our work offset. We can update our WCS, update our rotation, things like that. And then we can actually add in G-code block as well to our actual cycle. So, if we want to add an operator message or something like that in, if a part is oversized, if a part's undersized, we can actually tell our operator directly through the code that they see on the machine. The first example that we're going to be going over here is going to be our calibration. So I'm going to go ahead and back out of this here, and then we'll go into an example here. So typically, the times that we want to calibrate our probe is when obviously we get a new stylus, things like that, when the probe system is first installed on the machine, or if you suspect a crash happened or something happened to the stylus here. So we're going to kind of go over that in Mastercam and see and show you how that cycle is going to work here. So if I have a probing routine all pulled up here, and I'll go over creating it from scratch here. But we can see that the probe here that we displayed, it's going to be our probe 25 that we selected. So zooming out a little bit here, we're actually going to get a depiction of our probe inside of Mastercam itself. The way that this works is you can maybe see inside of the tool list here, or the operations list here, that we're actually defining it as a lollipop mill. But that's just kind of how Mastercam's handling the geometry of the probe in the background there. So as we go around here, I'm just backplotting the cycle out. I'll go ahead and speed this up a bit. So if we look inside here just a bit, we can see our probe doing our calibration. It's going to get clock surfaces and then touch off in Z as well. So building this from scratch, we can actually create this new path here. I'm going to go ahead and pull up a probing example here. And then, as we said before, we're going to be selecting our probe calibration. So, like I said before, we're going to want to take note of the help information in the bottom of our window here. As we kind of go through all of this, it's going to give us examples. It's going to give us, explanations of the things that we have here, along with the visual representation of that. So it's definitely going to be helpful for people that are just starting out here. So in terms of our clocked versus our probed cycle, we're going to be wanting to do a probed cycle here. So as we see in our help menu here, when we choose clocked, we must know the exact XY position here. When we're in our probed artifact location, we're going to be able to jog down to this, generic, position of where we're going to be probing here, and then kind of do it that way here. So that's what we're going to do here. We're going to choose probed. So we're going to be selecting a ring gauge and a reference surface. That's going to be our Z value here. So in our center of the diagram here, we have our 3 dots to the side. If we hit those dots, it's going to be able to pull us into our Mastercam window here. So on top of that here, we can go ahead and select our center, and then we can give our artifact a diameter. I know this is a 1-inch true diameter here for our artifact, and then we're probing the inside of that here versus our outside. So I'm going to go ahead and give this a safety plane height. You're going to want to always do this when we're doing any of this in Mastercam here. So I'm just going to give it a quick 500 thousandths. And then in terms of all this should be all set out of the box. So just kind of explaining what these are really. Our standoff distance, as you can see here, it's going to be the distance between our nominal surface and then where that measurement's going to end. Over travel here is going to be how much more the probe can go, once it hits that surface. So when you're jogging down, that's kind of helpful here, because it'll actually go until it hits here. So just resizing this a little bit. So we've got a couple of these that you can kind of take a look at here. We can use retract heights as we're going to different points. That won't be necessary for this particular example. And then probably the most important one here is going to be our inspection depth. So this is going to be where we're actually off of the point that we selected inside of Mastercam. So we chose the origin at 0, 0, 0. It's going to go minus 200 thousandths into that bore there, and then go ahead and perform the calibration. So again, with our length calibration, we're going to want to select a point here. We get our 3 dots. We can go inside of Mastercam and select a point. So what I'm going to do is I'm going to use the quadrant here, and I'm going to use my shift click, and that's going to give me a reference point here. So I can go ahead and pull this out. We can say, or even a little bit further in between here, just so we're actually going to be able to touch the inside of that, or the top of that board, or the artifact there. So I'll go ahead and select enter, and then we've got ourselves a X dimension there, and I'll go ahead and say OK. So now we kind of went over it before in the beginning here, but we can go ahead and backplot this out just for good measure. So just going through here, fairly simple here. Just getting our probe calibrated before we even start with our cycles here. So if no one has any other questions on this, I'm going to actually go into my second, or I guess third at this point, example here. So this next one here is going to be an example of actually updating your G54 offsets and things like that, and actually tool setting, and then broken tool length reporting and things like that. So as we can see here, we've got, I'm going to actually display my stock for a second. So we've got our stock here, and then we've got our, let's see if I can turn my visibility on. This is going to be a boundary of representing the face of the actual part here. So I'm going to go ahead and get back into view here. So the first operation that I have in here is going to be a facing op. So it's going to be getting it down to our profile of that white boundary there. And then what we can do is actually update that Z level after we did that facing operation. So going back into our probing cycle here, this is just going to be the first one of our options here. It's going to be our probing just a measured point. So right when we pull up a inspection cycle here, depending on, no matter what we have in here, we're always going to get this inspection cycle. We're going to want to specify our safety plane before we go, and then some of our standoff and over travel distances that we kind of went over before in that previous example. So as we pull up our measured point here, we're going to be able to select a point here. So I can select this here, and then we have an approach point for this cycle as well. So what this is just coming in straight from Z. If we want to avoid, a fixture or something like that, we can, alter that as it needs be here. So we have stock allowance. Let's say, like Matt was saying, if you're using a casting or something like that here, or if we actually are just measuring the stock and we want to go off of the model, we can use a stock allowance and then, edit that value inside of here. For this particular example, we'll just leave that at no. And then we have pre-moves in our safety plane that we specify here. It's going to be just 1 inch absolute. And then the retract after our point's done, it's going to come right back up to that safety plane. So I can say OK here, and then fairly simple path here. We're just, touching right back off here. So I did want to show what this code looks like as we're coming out of Mastercam here. So let me go ahead and just hit G1 on my probe cycle here. I'm just going to post this out here. We'll just say, for example. So whenever we post out a probing path here, we're going to get this dialog that shows up. So we have the Renishaw machine file, which is going to be for the default posts. It's actually located if we go into probe data here, and then we have our default RenMFs here, and that just matches back up with our MP fan post. So I'm going to go ahead and select my default inch RenMF. And what a RenMF is a Renishaw machine configuration file. It's essentially a post processor that defines all the variables, all the parameters that we need to write to when we are posting out machine code, probing code to our CNCs. And then we have another directory here where we can specify where our NC file goes. If everything looks good there, we can go ahead and process our code. So at the end of any successful G1 cycle here, we can see it succeeded at the end of this here. We can have, if we have any errors possibly, they'll show up and do our dialog here as well. So upon hitting done, my default editor is going to show up here, and then we can actually see how long this code is that comes out here. What that's doing is it's outputting all of the macros that are associated with this here, and then if the actual code is meant to call those up, then we're actually going to be going into those subroutines here. So we can kind of see what that code looks like a little bit here as we go. And that's just for a point cycle here. So the machine code does get a bit hefty. We just wanted to make sure that the customer knows that this is what they're dealing with here. It really makes it a lot more flexible because you have all the information available to you, no matter how much we're posting out here. So I'm going to go ahead and close this out here, and we can go into another one of our examples. So inside of here, I've got this area kind of just dynamic milled out, and then I created a stock model just to display what we're showing here. I believe we're going zero stock on the floors and then 150 on the walls. So after we do that cycle here, we're going to go into our probing dialog. So what this probing cycle is doing is it's measuring that point on the floor of our cycle here. So we have an approach point just like we saw in the previous example here. And then the other thing that we see here in this particular probing toolpath here is we see a machine update. So that's the first time that we've seen that here. It's going to be this icon on this side here. So whenever we pull up a machine update function inside of one of the probing paths, we're going to be, prompted to choose an update type. So this one is going to be a WCS update. We can update tool length, tool diameter, machine variables, and then a rotation as well. So this point actually only, it's smart enough to know that this point is only going to be updating Z. If we were doing something like a corner or something like that, then it would prompt us to update X and Y as well here. So we'll go ahead and we'll cover some of these other variables a little bit later, but we'll just say OK. And then we'll check out our second path here, which is going to be updating X and Y. So going back into here, we have another machine update, but instead of just a point, we're actually measuring a webbed pocket, which is going to be our icon right here. So I'll actually pull up a blank one just to show you guys, how to start this from scratch here, because it's a little bit more involved than just a point here. So I'll go into my probing dialog. I'll go pull up a measured web pocket. So inside of my safety plane here, looks like we are at Z0 for the top of our face of our part. So that safety plane of 1 should be okay. And then we can go ahead and go into our points that we're selecting for our toolpath here. So what we can do is go into our selection window here. And then this box is defining the stock that we're using for our machine. I can go ahead and use let me go ahead and use this. So I'll use the actual solid model to program this instead of our wire frame. So I'll go ahead and select, let's do this point here. So using the temporary midpoint, I'm going to be able to get the center of that line. And then I'll go into my second box here, and that point needs to match up exactly across our value here. So we can go ahead and temporary midpoint this, highlight, and then we've got our point here as well. So for our width, that's going to be the opposite dimension that we're selecting here. So we can go ahead and zoom out a bit into our 3 dots. And then on our model, we have our midpoint and our midpoint there. So we have a inside-outside as well here. Toolpath clearance, it's just going to be able to specify, where we want our points to land up on here. Measure ends. Our inspection depth, we'll keep that at 200 thousandths. And then measure ends is going to be the actual corners of the toolpath there. So the points per side, we'll see that once we output our path. And then shortest distance compared to linear. We'll go over both of those here. So we'll start off with linear, and then we'll show you specific or shortest distance. So now doing this here, if I calculate out my path here, it's going to be hitting on 3 sides of my length here, hitting on 3 sides of my width, and then measuring the other sides here. So then we're getting a specific X and Y dimension for our path here. So that's with our shortest distance option selected here. What we can actually select here as well is we can go into here and then change this to shortest distance and then regenerate our path. And then we can see that it makes these shorter moves here. So that's going to be a little bit more, I would say, geared towards, more complex geometries here. But for this, it's just kind of a good example and showing you what that is here. So puts that, outputs that. So in terms of the machine update that we select here as well, we can say NC update. and then we have a WCS update. So we can choose to use X or Y, and then we can say no to Z since we already updated that with our previous probing cycle there. And then we can select the feature that we're trying to grab the values from. So it's going to bring up this dialog with all the other probing cycles that we have in our file here. This is going to be our web pocket 2. We say OK. And then depending on what variables that we spit out to the machine that we're specifying in the renmf, those values are going to be updated to the machine directly. So just regenerating that. So that's just kind of how we, a little bit of an example of a couple paths inside of probing, and then some of the NC update functions as well here. So moving on to our next path here, I'm going to take off my stock here so we can just show our model. So if I expand the first path that I have inside of here, our probing cycle is going to be tool setting. So if you do have a Renishaw tool setter installed on your machine, we can actually program those things out. You know, and those can be used as we go here, you know, for checking tools, you know, if we can give it tolerances, things like that here. And that's going to be involved in a lot of our broken tool length calculation here. So before we go back to this, we can specify a tool ID. So if we see in our file here, we have tool number 2 is going to be doing a lot of our dynamic milling and tool pathing in the file here. So if we have a lot of heavy work on one tool, we can go ahead and go back to these specific areas here, and then check if that tool got chipped, if the tool offset needs to be updated, things like that. So as we go here, we see we're doing quite a bit with this tool 2 here. So I'm going to go ahead and close these out. So after we do a lot of that work here, we can go ahead and check to see if our tool got broken in the process here. So inside of our parameters, we can go to tool setting, give it a tool change ID of what we want to choose. The measurement type is a broken tool length. We can give it an offset number if need be as well. And then we set a tolerance for how much that value needs to be within to consider it a broken tool or not. So kind of like Matt was saying here, it would be very good for lights out manufacturing, things like that, just to be able to check if that tool does break in the middle of a cycle there, and then we can go ahead and stop our path. All right. So I'm going to go ahead and close up this example here. And then we'll go into our 5th example. All right. So we're going to head into another one of our examples here. It's going to display a bit of our other functions side of Productivity Plus here. So just like before in our previous example, I have a level with my stock defined. So I'm going to go ahead and get into our probing cycle here. So this is going to be displaying our measuring a 3D corner. So before we start off, like we said, for just picking up tool offsets and things like that, Productivity Plus is not going to be geared towards, just the simple kind of functions inside of that. We're going to want to be able to, focus on the main, more advanced kind of things, rotation updates, things like that. But we can, this example is kind of to show you that we can actually pick up a work offset as well here. So this inspection cycle here, we're measuring a 3D corner, and then the point that we choose is going to be our Z0, XYZ0. And then we have, we can choose to use stock, things like that. In terms of our position, this matters here with how we define going into the part here. So if we select position 2 instead of position 1 here, and we go ahead, we see that that motion is completely different here. So now we're going to be violating that part. So the position change will change inside of our help menu here as well to kind of display that. So P1 would be that right side corner here, or P2 would be the right side corner. P1 is going to be what we need here on this side. So going through that, we have just touching off in X, touching off in Z, and then touching off in Y. And like we said before, we're updating our machine update. So we have a WCS update setting from a feature, and then the feature is going to be set WCS, which is our measured 3D corner. Okay, so going through another example here. We can reset the Z after facing. We kind of already went about that here. So we don't have to go through this one here. It's exactly the same example as we did before here. So let's go ahead and check that tool. We see we do a lot of dynamic on this one here as well. And now we're tool setting, checking that tool 6. And then we're giving that a tolerance here as well, I believe of 115 thousandths. Okay. So getting into a little bit of the more advanced features here. So in operation 19 here, we can actually choose to reset wear geometry from our tools directly through Productivity Plus. So depending on where we store those values here, we can actually write the actual values that we need to for those tools there. So for 2606, we're setting it to 10 thousandths, and then 2406 as well. We can set that to 0. Likewise here. Okay. All right, let's see here. So for operation 24 here, we're doing a helix bore. Oops, excuse me. Doing a helix bore on some of these features here on the part, and then going in and probing our cycle here. So kind of the same process that we're going through here as well. In terms of these bosses here, we're probing them to reset the wear geometry. And then we're going in and actually inspecting these. So as we were saying before, we have the opportunity to construct different geometry as well with probing. So we're measuring these circles here of our bosses on the actual face of the part. We're measuring all 4 of them, and then we're constructing a point or a circle with all the references for those circles there. So I'm going to go ahead and kind of display this directly here. I'll pull up a probing operation. So we can go ahead and probe the circles of these guys here. So let's go ahead and select our guys here. Then we just hit enter as we're doing that here. So let's go ahead and give it. So we have it's kind of a smarter diameter here or dialogue here in terms of what, if we do get any error messages and things like that, it'll actually show us what we have to do here in terms of changing those values to get it back here. So let me go ahead. We'll pull up a previous cycle. So depending on what stylus we have, it's going to matter with what our probing cycle outputs there. So going back into here, we can construct a circle. And in terms of the values that we need to get those, that constructed circle, it needs to be in the same probing dialog. So we're not able to grab any of the positions here. I just wanted to display a little bit of how that's going to be working there. So in terms of constructing that circle here, so to reference any centers of these guys here, all we're going to need to do is, if it's in the same dialog here in our constructed circle option, all we need to do is drag that down here. So right now we don't have 3. We can reference that inside of there, and then we can have a position reference to our center. And then we can update that center, or that circle diameter. We can update that to a machine variable with our NC update function. And then we can set that to whatever we'd like here inside of our machine. So, and then the value that we select is going to be our boss underscore circle diameter there. So if that's making sense, we can go ahead and move on here. We'll come back to the reporting features a little bit later once we get done with this here. So our next example is going to be a 3+2 example with probing. So as we can see right now, we're just getting the diameter of our circle here. We can NC update that to a machine variable, just depending on what we want to do here. Right now, we're just measuring off that circle on the top of the part here. No big deal there. Kind of went over that. So next is going to be probing the inside of this slot here. That's going to be another one of our webbed pocket routines. And it's going to work the same way here. We're going to want to select a point on each side of here, and then a point on the tops to get our width. And then obviously we're working on a slot here, so we're going to go on the inside. And then we set a safety plane. So since this part is up, up higher in Mastercam, kind of where it would be fixtured at, we set a safety plane at a bit higher than the points that we're seeing here. If we were to make this a smaller value, then we get a warning message into our dialog here, and then hovering over those, the safety plane is below where we're actually probing, so it'll tell you that. So let me back out here. So in terms of that, fairly simple here. We're just doing 3 points, shortest distance, and then grabbing the 2 endpoints there as well. So now, getting into a little bit of more of the positional work, 3+2 work here. So we see that, like any 3+2 work in Mastercam, we want to set our T-plane to something different than our top plane to enact the machine to make that rotation. I use the whole whole axis function inside of Mastercam to get these this geometry here, and I was able to create those planes directly off of that geometry that was created. So going into our probing cycles here, we're going to be going into our parameters here, and under our inspection cycle, we have our probe name, safety height, and then the current CS. Previously, all we've been dealing with is top. But if we go into our 3 dots here, we can go ahead and select it from our planes manager. So outside of that, we can go and select kind of the same way that we have been with our points here. And then we can actually see what we're doing here for how this outputs in backplot. So we can see we're probing to each one of these holes here, and the machine's making that rotation as we go. So super easy inside of Productivity Plus. Works the exact same way if you're doing anything positional in Mastercam as well. Okay. not much to it there. We can hop into another one of our rotational examples here. So as Matt was kind of talking about castings a little bit earlier, this would be kind of a good candidate for a part that would be like this here. So as we can see, if we go to a top view, we have a measurement from the center of this circle here and the center of this one. And we see that it's got a measurement of 4.48 degrees, 468 degrees. If we go back into our Productivity Plus toolpath, we see that we're measuring out the circle of here, circle here, and then our inspection cycle is a constructed line in between the 2 points that we selected here. And then outside of that, we're doing a rotation update based on that feature of the line that we created. So I'll go ahead and enact this here. Let's pull up a probing cycle. I'm going to probe a circle. Let me get into a better view here. I'm going to select my guy there, say OK. I'm going to go ahead and select a safety plane that's suitable for this specific cycle here. So yeah, OK. So I'm going to keep going back into this process here, and then we can see how we can update this. So we're measuring that circle, going back into our parameters. We can go ahead and measure our circle here. Inspection depth, the same as what we've been looking at here. So we say OK, and now we've got 2 cycles measuring 2 diameters of those bores. So now going back into our cycle here, we can actually select a constructed line. So when we pull open these dialog boxes here, we can actually drag these down. Oops, excuse me. Let me back out of that quick here. So we'll say a constructed line. We're referencing to the diameter of our circle here. So we wait until that little dialog box shows up when we drag it on top of this here. So we see that little arrow on top of here. So the 2 points that now we're referencing here is going to be the centers of those circles. And we're not using a measured Z height for either of those. So we can go ahead and say OK, regenerate that, and now we can update that machine variable as well to display that. As we see in our original operation here, we're using a rotational update with our feature. We're rotating about Z, and then our G value here is going to be whatever we specify. So that's kind of simulating what the control is going to be spitting out, that 4.4868 here. And then we have a G code block inside of our probing dialog that's actually writing that angular value to update that for that variable. So whatever the current value that it sees inside of there, it's going to be subtracting by the value that it measures, essentially. And then we're just doing our specific laundry line here for our code. All right, so that's kind of how you would do a rotational update inside of Productivity Plus there. For something like a casting or things like that you're not exactly sure what that angle is going to be when we're rotating here. Okay. So as we're going on here, I'm going to select this new example here, and this is going to enact some of our if-then statements to quickly and intelligently remachine a part. So just going through our list here, we have our first parameter here, and this is just going to be what we call a label inside of Productivity Plus. So a label is pretty much a benchmark inside of the software that we can choose to skip back to a certain label inside of the code and then remachine that product there. So as we can see, we've got a helix bore on this feature here, and then after that helix bore, we have this probing cycle that's measuring the circle out. So if we go into our inspection cycle, typically what we've been seeing typically here are our measured circle. And then we have this new feature inside of here, and that's going to be our if-then statements. So that's going to be inside of our right side of the menu here in Productivity Plus. So if we right click on our first option here, the if statement, we can show that statement dialog. And then it pops up this condition builder here. So we can go ahead and select, if we measure a circle here, we can go ahead and select a certain feature off that circle. And then I know that that bore is supposed to be 1 inch directly here. So it's we can output the measure the circle diameter. And if it's less than 1, then we can go ahead and create our logic statements after that here. So if it's less than 1, then we can display a message to our operator saying it's undersized. And then we can update the tool diameter on our machine as well here, off the feature that we selected here. So we have an if-else statement. So if it matches the less than, then it's going to go to our then statement. If it does not match our if-then statement, then we're going to our else, and then that's just displaying to the operator that our size is big enough. So if it doesn't meet either of those conditions as well, so this is going to be when our condition is greater than 1 here, so that would mean it's oversized. Now we're going to that label that we selected here in the front of our file, and we're saying that it's going to that oversized label there. So oversized here, if we go into our parameters, we have that label, and then we have a G-code block saying that our part's scrapped, and then we're ending out our program. So these can be intelligently built to remachine, to get your shop up to lights out, or just get more, I guess, automated in your processes here. So that's a kind of a quick, simple example here. I'm going to head back to one of the previous examples that we had to kind of close up here, and that's going to be the one that our comprehensive example that we showed before here. So as we're going with this here, we can open up our cycle here. It's going to be, we have quite a few if-then statements here. So we're measuring the circle of our boss. So that's going to be all of our 4 pins here. And then like we did before, we're constructing that circle. So if that constructed circle's boss here, if that is greater than, the material condition is greater than 3 thousandths, then we're updating the machine to update that tool diameter, which means that part's oversized. So it's going to go back to that label beforehand, label bosses here. Outside of that, if it's less than, then we can update this as well here. Bosses have measured undersized, part is scrapped. And then we update to set that new boss diameter here as well. So if that boss circle is greater than 4.35, it looks like this is measuring another one of us here in terms of our boss circle there. So we've got a few G-code blocks out of that here as well. So that's typically how we work with the if-then statements inside of Productivity Plus. It's just fairly simple, logic statements, to enact a lot more efficiency in your processes here. So the last thing that I do want to cover is going to be the reporting features inside of Productivity Plus. So if we go into our last operation here, we have a reporting cycle. And depending on if that's reporting out to through the deep print on the machine, if we're, directing all the way back to our programming station, we can actually measure out these points and then throw them back to a certain system through a report here. So we're measuring our pocket depth in our top face. inspection cycle 1. So we can report all of this kind of things out here, and then reference out to this stuff here as well. All right. Matt, do you have any other kind of things that we want to go over? I feel like
we just had a question from Robert Kemke there. Would you be able to set it up to program run the routine every so many parts?
Yeah, definitely. So depending on what labels that we select and things like that, we can actually add counters inside of the control. So if we write a value to a variable on the machine, every time that we reach that label, we can have that counter update by 1. And then we can have another if-then statement inside of our control that is effectively, once we get to 10, then we're going to be going to another label in the program, and then we're going to be finishing out there. So that's definitely doable there, Robert.
Thanks again, everybody, for attending, and we'll talk to you soon.
Thank you.